Welcome back, guys. So yeah, where did we leave off last week? Uh, I guess we wrote some to do. Yeah, let's just check that and get started. We fixed the setup. I guess that was old. Yeah. Check why our process is not able to switch and why the page table for GIC is not working. So now we are jumping into some sort of loop. What is going on there? Okay. I thought we wrote something else. I remember debugging an issue. What was that actually? I don't remember exactly. But it has something to do with this map page table entry, because what I was trying to do here is that I am creating new L2 entries. So I'm creating new L3 entries. So I need L2 tables for every I need L2 table, and then the table will contain the L3 entries. So I need a location to store that L2 table. That's why we have this, and we added it in our linker. And I remember that part. So okay, that's fine. And what worked and what didn't work? What exactly are we currently stuck? Let's just build it and see where we are. So we are in this pointer, and it just does not allocate anything. And if we tail the Kemu log, we get a exception, and the exception is 4.3, which is 4.3 is L. Which level? Let's just Google this. This is the new one. Okay, let's just check the level, and then let's just bring back our own context, because I'm a bit out of context here. It's been a week, so yeah. It should be L3 faults. Okay, level 3 faults. So it did not find the entry within L3. Okay, so we were able to find the L2 index. What do we do here? What is this? Let's access, find the L1 index for this and create a L1 table, then constant, and it will have 1 GB of, it should be 3 in this case. Okay. And we have the L2 index, current L2, and then we create virtual, we get the virtual address, we calculate the L2 index, we create a L3. Okay, I just remembered, because to confirm if the problem is with the actual L3 table, or the problem is is with my linker, because I created a space and I'm trying to add then L3 tables within them, no, L2 tables within them. So just to be sure, I just created a static L3 table and added it, and just to check if the issue was not there. So let's just keep this set up first of all. So we have a static L3 table, and which will be added to the index in L2. So we have L2 table, L2 index, and we add the L3 table address as the descriptor. So I guess this line is fine. So we added the L2 index with L3 table address. Now we get into L3. Now we want to get the index, and then we make the block descriptor for the actual physical, because this is the final thing. So we need to map the actual physical address where we want to put it. Make L3 block, and we set the table entry. Okay, so here we need to confirm two things: whether we are creating the L3, because we have L3 error, so definitely L2 entry was fine. We were able to get some sort of thing and it went into L3. Or maybe we just had random junk here and that's why we came to L3. Is that possible? No. A specific entry needs to be set to 1, only then the L2 entry will consider that there is a block for this. So definitely L2 entry did work. So we have the L3 entry, that is the problematic one, I believe. So let's go to L3. We have what exactly is an L3 entry? So L3, and let's just check it. For L3 we have a page descriptor, so we put the entire physical address here, that is the outer block address, and I don't know what the lower bits are, but the final two things needs to be set as 1 1. So what do we do here? We have disk valid, which is in the 0th bit we are setting 1, and in the first bit we are setting 1. So it is 1 1. That's fine. And we are also setting this in the 10th bit. Okay, and we are getting the physical and we are adding it with FFFFF, not at FFFF. That means only these three upper nibbles will be zeroed and everything else will stay the same. Do we need this? Yes, because the upper bits should stay the same, and our physical address should start from 47th bit, I guess. So that's why we shift it 12 times to the left or to the right. To the left, I guess. If we shift it down to the left, 12 times. What does that mean? So the least significant bit is moving 12 times. I guess that should be, you know, maybe L3 entries are of 4 KB. Are of 4 KB, right? 4 KB 512 entry. So one index can store 412 4 KB. We make L3 block. L3 block to calculate the index we start from 12, so I think this part is just fine. After that, we are trying to make this block, and this block okay. This is the block, and we want to, okay, let's see, let's just try one thing, that is to confirm which address are we writing to, which index are we writing to. So we have the L3 index, and we wrote to the 0th index and then the first index. Yeah, because we are trying to map 4 pages, so we wrote into 0, 1, 2 and 3. We are mapping the respective physical PA. Wait, probably that's the issue, because PA seems to be static, and I guess maybe I also have to update PA like this, because PA needs to be also be updated. What exactly I'm trying to do here? I have a page, I have a virtual address. I need to map it to the physical address, and in case the total is more than 1, that means I need to map more than one page. In that case, for the first virtual address, I map it to the first PA, and for the second virtual address, which would be virtual address plus 4096. I need to map it to physical address plus 4096, right? I think that is what I fucked up. I don't know, I'll just try. So it would be current PA. What the fuck did I type? Physical. Okay. So now if we try to access something, I don't know. I would think that's how it should be, because every entry is just 4 KB. We still have L3. Yeah, okay, what exactly are we trying to read? We are trying to read just after this. We have the pointer, and then we are trying to read the 0th bit. So it should be the first address. So I think even the first address is not working. So maybe we'll try to add a static entry and see if it's working, and then we'll think about the rest. So we have the current PA. Current PA. For current PA, we calculate the L. What's this L2 index 3 base physical? So this is the L2. This is the L2 table. Make table descriptor L2 table base physical, L1 base physical, L1 index, L1 descriptor. What is this again? For L2 index in L1 index. Within L1 table, we are adding this L3 index. For which L3 descriptor, for which index? For index 3, which is for this address. Because as you remember, we have only mapping for 0x80002, the address before this, which will be the index 2. So we need for index 3. So when we reach this function, we add one more entry. That is fine. So we have an L1 entry for this, and then we need to create the L2 entry. So we create a table which is this is the L2 table that was added into L1. Now, so this is the L2 table. Within that table, we can add up to 1 GB. So we calculate the index for the current VA. We calculate the index for the current VA. And what is the L2 index? And L2 index is always going to be 0. Why? Because L2 is up to 2 MB and all our 4 pages are going to be within the first index. So within L2 table, within the L2 index, we are adding a table descriptor that is of L3 index 0 base, and that is placed at 00B000. Must be 496 aligned. So maybe I can put it as A. B is 11, C is 12, D is 13, E is 14, F is 15. So maybe let's try C. No improvement, so it's not some alignment issue. Okay, now we have the base. This is the base, which would be AC000. Now we make a table descriptor out of this table. Why do we make a table? Okay, that is for L2. We create the L3 index. Table descriptor out of that L3 table address, and we added that entry. Let's just make this like this. So we have the separation. This is for L2. This is for L3. In L3, we calculate the index for the current VA, and we make the L3 descriptor for the physical VA. And this is the only thing I'm not completely sure, because this is little bit different because we need some extra data here. Maybe that's the extra data I'm not adding. Because usually if you're making a block descriptor, what we do here is this: we remove the upper bits, we shift it, we shift everything to right, and then we shift everything to back to 12. What the fuck is this? What is this even doing? We have we are zeroing out the upper three nibbles. That's fine. And then we are right shifting 12 times. So we can remove the final bits. Okay, this is just to zero the final bits. Okay, let's just write it down. Right, zero the upper part, right shift to zero the final 12 bits, then again left shift to move it back to its position. This is what I have done. And would that work in this case? It won't, because we need everything. We need every bit of information. So we zero the upper bits. And just directly shift everything to 12th bit. I guess this is the issue. We just we are zeroing something and the address is currently the same. Now if we are simply moving 12 bits, we are losing data in front. Here we can lose 12 bits because we want to zero it. That's why we moved forward and then backward. So we lost 12 bits, which is not needed, and we placed it back. Here we just call 12 bits, then we are just simply losing 12 bits, which is not good. I think I have to put it in the 47th bit. But I don't know, we don't really lose anything in the front. Because we only use 47 bits for indexing because that's the current VA. So we don't really need the upper bits anyway. So if we move it, probably we are overwriting the upper bits. That's why this is fucked up. In that case, let me just first shift it 12 bits and then shift it 12 and then I'll do the AND. What will happen now? Nothing happened. We still have the same here. Okay, now it's time to get into disassemble gaming. What exactly I want to stop? Maybe I'll just put a test me here. Yeah, that would be fast. Okay, fuck it. Disassemble test me. Now if we go back, now we can return and we are back here. Now this is that statement. Now what we have to do is we move this, we move this, we move this. Now we have to check what is in X9. And we get in false. I get, even for B, I'm getting an error. Why? Shouldn't everything be already be mapped? Maybe we overwrote something and we fucked up something. Even 8FFFFF is not accessible. Maybe that's because I only have L2 entries for 2 MB. Yeah, I only have L2 blocks for 2 MB. I have one L1 entry because now if I check the log, I have a L1 entry for 1 GB, but L2 entry is only of a block, probably for 2 MB. That's why it's not working. Yep. For L2 entries, I have 2 blocks. One block is for of L2, a single block is of 2 MB, and I have a block here which is from 8000, and I have another block that is here that starts from here. That's also fine. Now I'm trying to create a L1 index with a new L2 table. And within that L2 table, I have added a L3 entry, and that L3 has an index which is marked as the physical. Fuck, everything looks just fine. Make block descriptor. We don't need this. We'll remove this part. Index is fine. Index is working fine. Now the actual block descriptor is the one that is probably fucking with us. Maybe let's clear table L3 to, I'll clear this too, just to be sure that there's nothing there. Okay, it's time to look into the table then. Now if we do this, we're not able to access that, so let's just try the table now. This is the new table, which is the L3 index. Let's try that. We have something. What do we have? This is the first one. I think we should read from here to here. So it's like 0000, and we have a C, and then we have 0000 and 3. Is that how it should look? How it should look is the table first index should have the actual physical address, mm, and the valid bit set, which is 1 1, which is 3. That's why we have the 3 here, so it is just fine. Okay, it's and we also have another entry, that is C0001, and that's also set with 3. And another entry which is set with 2, and another entry that is set with 3. Wait, I have one doubt. Maybe, just maybe, because even the physical address is not really physical, right? Because yeah, I think that might be the issue. What I'm thinking, I don't know if it's correct or wrong, but if we check the old code inside our MMU init, inside the index, L2 index, we have two L2 indexes. We have one that is mapped to the actual physical kernel base, which is 8000. Virtual kernel base to physical kernel base. And we have another one, which is the physical kernel base to physical kernel base. Maybe this is what we need. Maybe we need the actual entry, because even now, when we actually try to reach this, no, MMU is supposed to treat it as a physical. No, I'm just confusing it. MMU, if it walks down the path, it's not going to consider it as a physical. It's just going to it's going to consider it as a physical. So this is not the issue. I'm just considering it, just taking it as wrong. This is not the case. That was wrong. This case was valid because we had existing physical addresses, and that went through MMU. But currently MMU is already there, and MMU has a physical address, so MMU should be able to access it. That's the thing. This is what we have to figure out. It's here. The physical address. I have taken it as C0000. If I try to access that, it should go through it and it should reach this. What's physical base address and page shift? What's this? Can't bit index to physical. We got the physical. And we do this to get the virtual address. How do we get it? Physical base page plus bitmap page into 8 plus bit. Okay, that's fine. But what is this? Physical page, and I have to shift it 12. Why do I have to shift it 12? Sometimes I don't fucking understand my codes. We get a physical page and we shift it. Okay. This is just to do that array map because the final 12 bits are actually used as the index. That's why we keep it as shifted, and then we do the index calculation, and finally we shift it back because the final bits should always be 0. That's fine. And we get the VA and we try to map it. And here we have a global VA, which is just to try to add the L2 index. And what do we do? We have the L2 index, and within L2 index we try to create the L3 base, and we set the entry. L2 table descriptor. Mm. What can I hard code to get something? Okay, instead of trying this, what if I try to map it to a physical VA that I know? It's A, right? B, C, D. Let's try E. Let's try this. And now what was there? We still have an L3. Why? When we walk the table, we reach L3 index and we get... Okay, I got it. I know what to do. Let's just fill everything within that index. This is the best case scenario. If every index within L3 has an entry, then it should at least work. How many indexes are there? Let's put 512. Now let's try. We are just mapping 512 indexes. And we still have a same year. So this is not a L3 index errors. Our L2 map table is the issue. I'm pretty sure now. Because we try to reach this address and it says it's an L3 error. But it's not possible because every index within that table has an entry. Every index within that table, which is just always 0. So the table should also be fine, the L2 table. And L3 table has 512 indices, and we wrote a physical address to everything. So if the walk was actually erroring in the L3, then we should have got an entry here. Or maybe it's erroring out for a different. What's the entry? It's FFFFF. So the L1 index is definitely 0. L2 index is also 0. And L3 index would be something here. Currently what I have done is just added 512 entries, but the actual value would still be this is L2. L2 we have a base. What is this base? It's 0 0 0 3 4 1 2 3 4 8 0 0 0, and then we have the L3 index, which is 0 0 0 C, and I'm pretty sure we never used that address anywhere because stack top is F and stack grows downwards. Oh, stack grows downwards. Wait. Maybe stack is overriding this. Let's break at this point. Continue it. Still, even then, did we actually use that much memory in stack? That's not possible. Even if it grows downwards and it's overwriting below our address. Now let's check what is the registers SP, and it's EFFF 0. Okay, so it is growing downwards because E I started off at I started off at F. Now it's decrementing and it's in EFFF something. So we are actually writing into this. That's not good. So maybe I have to put stack top somewhere else. What could I put there? I should also make sure that that has an actual entry, but still it is only FFFF90. What did we write to? We are in C, so there's just so much space there. We could have never reached that point. Okay. So at least right now this shouldn't be an issue because stack only starts at what? Did I change something? I removed F. Stack starts at F and we kept the index around C and I'm pretty sure that was clean. Maybe we could call this clean there once when we first get into this. We also clean up this table once. And then we add the L2 index. L2 index, we add the L3 table. And within L3 table, maybe we also have to think about how exactly adding L3 table. In L3, no, in L2, if we want to add a table, we just give 1, so that should be just fine. Let's change this and see if we get a L2 error. Let's change this to, this is too much. Let's just put 5. No, let's just put total. Okay, so we did get a, let's just double check this. So here, if I write into simply in L2 tab in L2, if I write to the 12th index this table L3 table, we get an L2 error. It is a translation fault L2, and it's a right axis. And if I change it back to 0, which is the actual valid one, I get L3. So definitely L2 is working. Inside L2, the 0th index is what we need, because L2 can have 2 MB and it's the 0th index, so that's definitely fine. So this is definitely working. But L3, in L3, what are we trying to read in L3? Because we try to set L3 index to all 512 entries and still we got an error, even if we set all the 512 entry blocks. So probably that means this block entry is the issue. So we are back to square one, because what are the things we confirmed? Let's just write it down. We confirmed L2 index is 0 by writing a different L2 index, and we got a L2 false, and we wrote all 512 index in L3, and we still got an L3 false. That means only thing that's left is to check the actual block implementation. And the block is this. Can we write a static L3? For 48-bit VA and 4 KB page size. What is an example L3 page entry example. Yes, we have to set 0 and the first bit to 1 1. We have set that. Yes, we have set that part. And the 47th bit to the 12th bit should be the output address 4 KB aligned. Maybe that's the issue. Is our input address 4 KB aligned? I think so. Well, let's just assume that it is 4 KB aligned. In that case, I'm just shifting it 12. So the final bit will start from the 12th bit. And then I'm removing the upper bits. So this is definitely fine. So we also have to set the AF bit. Okay, let's just set that AF bit then. We have set the AF bit to, maybe now we can try after setting the AF bit. Let's try that 512 test. 512 test case where we add index to everything. 0th index, which is just L2 index, and L3 index, which is add all 512 entries. So we have 512 entries, so no matter which index that was taken by the MMU, there must be a value which would be just which would be just a page entry. And we still get the same fucking error. We get the same EL3 error. This is what we are trying to access. To this. Let's see if we have that. Oh shit. I mean, we did check the address. It did have zeros, the value 3 and the C. 3 just means 1 1. So the value looked just fine. Now we also have that AF bit, so maybe we can also check that. So this is exactly fine. I think it's just perfectly fine. We don't really need those extra bits. See, this is the minimal version. Page descriptor and AF set. That's all we need. And if we come here, we have 1, 2, 3, 5 zeros. Okay, we have extra zeros in front. Maybe that's the issue. Okay, let's just oh, fuck me. So, I mean, that is fine. I know that I have to read from here to here. So, the value, what you said is, I guess the shifting is the wrong, I guess. Oh, dude, it's just fucking same thing. 0 1 1 1 1. I don't need those extra fucking stuff. I don't need anything else. So if this, maybe I just don't have to shift anything. 1 2 3 4 1 2 3 4. Okay, let's try that. We'll just change this one thing. We don't shift anything. Shift it 0 times. No, I have to wait for this. No, that's not going to work. Where is it? Just put it. I can confirm that second time. It worked. It fucking worked. Oh my fucking god. It did work. See, here we mapped 4 entries, and then we have wrote 102, that is F, and then we also have wrote where is it? Yeah, we wrote F-O-R-K, and also into the 1300 index I also wrote F. So I'm also reading that to check if we are able to read that memory. Okay, so we did manage to figure it out. Okay, let's just do one more thing. So this is walking. So what did we do? We have fixed the main culprit, which is, as we initially thought, is just we didn't hard code anything else, right? The index is still dynamic, and we also fixed this part because we also calculated PA. We fixed this one, and other than that, maybe we cleared the table here. We didn't do much. And the biggest issue, as I knew, was just this shifting, and we don't have to shift it that way, and this is just fine because we have to set it to 1 1, and we also set AF bit. That is also needed. Other than that, we don't have to do anything else. Okay. Now what do we do? No. Yeah, let's just do this part, because right now one thing is hard coded, that is this this L3 table is currently hard coded. We don't want that. We'll just use this. We'll try this. nothing much. Because now we'll use this memory. And currently we have only given 10. So if we go past 10, we'll get an error. We try to allocate more than 10 L3 tables, will get error update with this in linker. Okay, let's see if this works. What the fuck? What was that error? What is this? Okay, I need this. Okay, I just remembered why we need that, because I was hard coding this address here. Let's just put that. It was L3 and we'll comment this line, and this is the only thing that we need. Okay, now it's again the same fucking error. Now what's the but we have a different error. It's some 4F. Okay. What was the address? And we tried to access this. It was permission fault. Why? This is just a random memory that I'm allocating here, and I'm using it here. Why does it throw? Why does it throw this? Was this raises a permission fault? First of all, this is just a random memory. Instead of hard coding this, I am taking it dynamically. There's no freaking other thing. Maybe then I'm not doing it correctly. We take the L2 memory start plus 512 into L2 index. And what is the L3 table address? This is the address. I mean, it should be just fine. Just decimal to hex. It's fine. Oh, it's not fine, because it's FFFFF. Okay. it makes sense. Okay, I get it. So what I have to do is that this is returning a virtual address, so I have to just mask it. So what do we do? And it with 0xFFFF, and I'll not it. Now everything else but this will be knotted. I think so. Nope, it did not do that. Address and FFFF. If I knot it, that would be 000 FFFFF. Then how the fuck did I get this? That's not right. But technically, if I write to this, it's just going to write to here, right? No, table addresses should be physical addresses. Yeah. So it should definitely be a physical address. So I think I just have to convert it into. Wait, I'm a bit confused. I can. The actual table address that I give in MMU should be physical address. So I can't use a virtual address there. And the linker script starts from 00, and if I access this, I'm getting a virtual address. And that virtual address, I just have to convert it into a physical address. And I hope that the address is already mapped. And I'm getting 808 here. I think 808 is used by someone is used here. L2 index 3. So let's just use L2 index as 7. I think the issue is still it's not converting it. It is not converting it properly, or I'm having a variable that's just not correct. If we go down, where's the print message? This is the L3 table address, and L3 table address is here. We take the address, we AND it with the FFFF. Mask is wrong. I just have to use this, so it's always my fucking faults. Hey. 0x. Okay. Now if we try it. Okay, now it's working. Okay, so we have the actual thing that is dynamically allocating L3 tables, and the L3 table will be allocated within this memory and we use it. We also figured out one issue, that is this L3 is starting from 0x800, and that memory was used previously by our L2 index. Now we just moved it to 7. But yeah, other than that, everything. But in general, right now, what we have done is right now the allocation is working in L3 level. Let's just add that in our k-main. Mapping of L3 entries is working now. If L3 entries is working now, then now the second thing we have to do, why the fuck did we start to fix the L3 entries? I don't remember at these points. Maybe it's because this GIC. I think so. Let's think about why we fixed L3 entry. Maybe we want to add GIC physical map. Okay, yeah, we'll try that in the next stream, but I guess at least now we are able to get the L3 entries working, so it's good. Okay, thank you guys. Bye bye.